Good evening, GCC College Algebra. How's everybody doing today? So tonight we're going to finish up Chapter 13, which finishes up our curriculum. We're going to get done with just a couple of concepts here, a couple of types of problems. Let me fix my... There we go. A little bit better. All right. So arithmetic sequences. Now remember, a sequence is a function that gives me an ordered list of numbers. So an arithmetic sequence is a special type. In fact, in 13.2, we're going to talk about something called an arithmetic sequence. And then 13.3, we're going to talk about another special type called the geometric sequence. So an arithmetic sequence is going to be defined as an ordered list of numbers Now, there's a special pattern, and it's all about this special pattern. An ordered list of numbers where each term has a common difference. Common difference. And we call that common difference D. All right? So they're all going to have a common difference. Now, some of the terminology here, when you see, remember, when we see A sub 1, that means the first term. A sub n means the general term. And as we saw before, you can think about this as a formula. It's the formula that generates the sequence. And D is the common difference. So let's take a look at some different sequences and see if we can tell, well, which ones are arithmetic and which ones are not arithmetic. So I'm going to put a couple of different sequences up here. First, let's have 2, 4, 6, 8, 10, dot, dot, dot. And then we'll have 2, 4, 8, 16, 32, dot, dot, dot. And then we'll have 2, 4, go up by 2, go up by 3, go up by 4, go up by 5, go up by 6, dot, dot, dot. And then we'll have, let's put some different ones up here. How about 14, 11, 8, 5, 2, dot, 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 and 1, 4, 9, 16, 25, dot, dot, dot. So here's a bunch of different sequences. And all I want to do is I want to take a look at them, and I want to decide, well, which ones are arithmetic? Which ones do the terms have a common difference? So we're going to compare terms. So on the first sequence here, 2, 4, 6, 8, 10. Notice it goes up by 2, up by 2, up by 2, up by 2. This is arithmetic. The common difference is 2. Now this one, notice there's definitely a pattern here. 2, 4, 8, 16, 32. Can you tell me what the next term is going to be? 64, right? Do we know what the next term on the first one was going to be? 12. 64, right? But do they have a common difference? Goes up by 2, goes up by 4, goes up by 8? No. So this is not arithmetic. How about here? It goes up by 2, and then it goes up by 3, and then it jumps up by 4, and 5, and 6. Not the same term each time. It doesn't have a common difference, so it's not arithmetic. 14, 11. Okay, so now this is going down by 3, to 8, down by 3, to 5, down by 3, down by 3. This is arithmetic. What's the common difference? Negative 3. How about this one? 1, 4, 9, 16. Goes up by 5. Or it goes up by 3, up by 5, up by 7. No, this is definitely not arithmetic. There's no common difference there. So it's not to say the ones that are not arithmetic are like bad sequences. There's lots of different types of sequences, and a lot of times, even if it's not arithmetic, you can recognize the pattern. You know what's going to come next. But it's the arithmetic ones, the ones that have a common difference. Those are the ones that I want to focus in on. So for those ones, the formulas usually look like nice, well-behaved straight lines. For example, if I have t sub n is defined as 4 minus n, and I want to find the first 5 terms. So we've done this before, but now after we find the first 5, I want to know, is this arithmetic, and what's the common difference? All right, so t sub 1, 4 minus 1 would be 3. There's my first term. T sub 2, which means my second term, 4 minus 2 would be 2. There's my second term. T sub 3, 4 minus 3, 1. There's my third term. T sub 4, 4 minus 4. There's my fourth term. T sub 5, 4 minus 5 is negative 1. There's my fifth term. So here's my sequence. 3, 2, 1, 0, negative 1. So as I take a look at this sequence, and I ask myself, is this sequence of numbers an arithmetic sequence? Yes. What's the common difference? Going down by 1, down by 1, down by 1, down by 1, the common difference is negative 1. So it is an arithmetic sequence with a common difference of negative 1. All right, if we have a sequence, we can find, now here, we were given this formula for a sequence, and we were asked to find the first 5 terms. Suppose I'm given a formula, so suppose I'm told that, let's see, s sub n equals 3n plus 5. Now, this is arithmetic, but suppose I want to find the 12th term. In other words, find s sub 12. This is s sequence here. S sub 12 means the 12th term. Well, I could go through and find the first and the second and the third and the fourth and the fifth, but I don't need to do all that. I can just plug it right in. S sub 12 is going to be 3 times 12 plus 5. 3 times 12, 36, plus 5, 41. The 12th term, s sub 12, is 41. So this is nice. Once I've got this formula here, this formula is called an explicit rule. So it's nice when you've got an explicit rule. You can find any term you want. Just plug that in there. If I wanted to find the 17th term, just plug 17 in there. But we don't always have a nice, well-behaved explicit rule. We might want to find an explicit rule. For example, find a rule for the following sequence. 7, 5, 3, 1, negative 1, dot, dot, dot. And then once I know the rule, then I could find like the 27th term. I mean, I could find the 27th term just by recognizing the pattern and then keep going until I get to the 27th term. But I'm going to find a rule. Now, to find a rule, we actually have a special formula. Here it is. The formula, a sub n, is given as a sub 1, which is the first term, plus the number of terms minus 1 times the common difference. This is the magic formula for arithmetic. Only works for arithmetic sequences. Only arithmetic. So, my formula, a sub n, is a sub 1, my first term, 7, plus n minus 1 times the common difference. What's the common difference here? 7 to 5 to 3 to 1 to negative 1. Going down by 2s, negative 2. If we simplify this, a sub n, 7, distribute, minus 2n, plus 2. A sub n, here comes the magic formula, is 9 minus 2n. So now I've got this formula for this sequence. Ready? Watch. A sub 1 is 9 minus 2 times 1. 9 minus 2 is 7. A sub 2 is 9 minus 2 times 2. 2 minus 4 is 5. A sub 3 is 9 minus 2 times 3. 2 times 3 is 6. 9 minus 6 is 3. And it keeps going. So we've created a magic formula. Now I can do something like find the 27th term. Find a sub 27, which is the 27th term. And I don't have to take this sequence and keep going. I can just plug it right into my formula. The 27th term is going to be, a sub 27 is going to be 9 minus 2 times 27. 9 minus 27, 40, 54. 9 minus 54 is negative 45. So my 27th term is negative 45. Find it just using the formula there. So this is an explicit rule. This formula here is an explicit rule. There's another way of generating a sequence. So an explicit rule is like a formula, but there's something else called another type. And so let's write this down here. Explicit rule is a formula, and we can think about it as a sub n equals a sub 1 plus n minus 1 times the common difference. And then that will help us to create a formula. But I could also have something called a recursive formula or a recursive rule. Recursive rule is a little bit different. The recursive rule, instead of being a nice formula like this, the recursive rule says a sub n equals the previous term, a sub n minus 1, plus a common difference. All right, so what I just wrote here in math, I'm going to read it in English. Okay? Any term is the previous term plus another common difference. Over here, let me read this one in English. Any term is the first term plus the number of terms minus 1 more common differences. Start with the first term, take the number of terms minus 1, common differences more, add it, and you'll get any term. Recursive rule. Any term is previous term plus a common difference. All right, so let's take a look at a recursively defined sequence. So, given that the first term is 3, and any term after that is a sub 1 plus 4. Find the first 5 terms. All right, so here we go. So I know a sub 1 by definition is 3. The next term is going to be the previous term plus 4. It's going to be 7. The next term, a sub 3, is going to be the previous term plus 4, 11. The next term is going to be the previous term plus 4, 15. The next term is going to be the previous term plus 4, 19. Notice how the previous term in fact here, 3. The recursive rule is always based on the previous term plus the common difference. This becomes a pain in the neck. What if I said, find the 27th term here? Well, in order to find the 27th term, I would have to know the 26th term. Oh, that should be n minus 1. Oh dear. N minus 1, right? The previous term, n minus 1. Previous term. There we go. If I wanted to know the 27th term, I would have to know the 26th term. Take the 26th term and add 4 to it. But to find the 26th term, I'd have to know the 25th term. To find the 25th term, I'd have to know the 24th term. To find the 24th term, I'd have to know the 23rd term. You can see what a pain this would be. There's no shortcut. When it's given to you as a recursive rule, there is no shortcut. If you want to find the 27th term, you're going to have to find them all the way leading up to that. That can be very frustrating. That can be very difficult here. All right, so let's take a look at a couple of sample problems. There's a lot more about sequences, by the way. If you look in your textbook, there's a lot more going on. So let's see. Given that S sub n equals n minus 5, let's find the difference and first 5 terms. This is problem number 8 in the exercise set, similar to some of the homework that you're going to have to do. All right, so S sub 1, which means the first term. 1 minus 5 is negative 4. S sub 2, the second term. 2 minus 5 is negative 3. S sub 3, the third term. 3 minus 5 is negative 2. S sub 4, the fourth term. 4 minus 5 is negative 1. S sub 5, the fifth term. 5 minus 5 is 0. So here's my sequence. I can clearly see it's arithmetic. What is the common difference? Negative 4, negative 3, negative 2, negative 1, plus 1. Add 1 each time. Clearly arithmetic. Let's take a look at another sample problem. A lot going on in this one. Suppose I tell you that I've got an arithmetic. This is problem number 20. I'm going to do problem number 20 here. An arithmetic sequence. And I'm going to tell you that a sub 1 is 6. What does that mean? And d equals negative 2. What does that mean? And I want to find a sub 51. What does that mean? All right, so what's going on here? A sub 1, that means my first term. D, that's my common difference, is negative 2. A sub 51 means my 51st term. So if I take a look at this sequence, I know my first term. My second term would be just subtract 2. My third term would subtract 2 again. Now, I could keep going 50 times, but that seems a little ridiculous. What I'm actually going to do is find a formula using that magic a sub n equals a sub 1 plus n minus 1 common differences. Any term is my first term, 6, plus n minus 1 times my common difference of negative 2. So I'm finding the formula for this sequence here. Distribute the negative 2, 6 minus 2n plus 2, 8 minus 2n. There's my magic formula. Now I'm going to use this magic formula to find the 51st term. A sub 51 is 8 minus 2 times 51. 8 minus 2 times 51 is 102. 8 minus 102 is negative 94. Okay. So my 51st term is negative 94. All right, one more. And we're going to do number 26 out of the exercise set. It's, suppose I tell you that the 80th term is, or no, I want you to find the 80th term of the following sequence. Negative 1, 1, 3, dot, dot, dot. Find the 80th term of that arithmetic sequence. All right, so given this arithmetic sequence, again, I'm going to find the formula and then use the formula. The formula says that any term is the first term plus the number of terms minus 1 common differences. So I'm saying it in English and I'm writing it in math. Any term is the first term plus the number of terms minus 1 common differences more. Substituting in, any term is, my first term is negative 1 plus n minus 1 common differences of, let's see, what's the common difference here? 2. Negative 1 plus 2n minus 2. Negative 3 plus 2n. There's my formula. So now I've got the formula. It's easy to find any term I want. Here I want to find the 80th term. A sub 80 equals negative 3 plus 2 times 80. Negative 3 plus 160. My 80th term is 157. Now there's a lot more going on with sequences that we can find. We can add them up and find sums and partial sums, and we can do all sorts of crazy things. And you'll see a lot more about this in future classes. This is just kind of an introduction, getting used to series and sequences and the different types. And so they're really, as far as arithmetic sequences go, this is all I want to do. If you look in the notes We only really got about halfway through 13.2, a little bit more than halfway through 13.2. You can certainly look at some of the other things in there, but those things you'll see more in future classes. This is just kind of an introduction to arithmetic sequences. All right, ladies and gentlemen, so that finishes 13.2. What I'd like you to do now is I want you to do the assignment for 13.2. The assignment for 13.2 starts on page 980, and I want you to do 5 through 9 odd. 5 is just a fill in the blank, just kind of a concept that question here. So looking at that, and then 7 and 9 are just generating the first 5 terms of a sequence. And then 15 through 19 odd, and those you're going to find the first term, or it gives you the first term and the common difference. Find the first few terms, or find a given term. Find a formula. That's what these ones are all about. And then 2 ones a little bit more interesting. I want you to do numbers 23 and 25. 23 is a little bit more awkward. The numbers are a little bit weirder here. You're going to have to deal with radicals. So the concept is the same, but the numbers you're going to deal with are going to be a little bit more difficult here. And then 25 is like the last problem we did. We did problem number 26 just before this, so very similar to number 26. Now, as soon as you've got the assignment completed, I want you to email me the completed assignment. All right, awesome. There we go. So not much, not doing an awful lot here, just kind of finishing up the chapter with some new concepts, some key concepts that we're going to see in future classes. All right, guys, good luck. Work on this. If you've got any questions, shoot me an email, and I will talk to you again soon. Bye.